Alrighty folks, here we go. We're now looking at some practice questions with identifying errors in deductive proofs. So let's take a gander at them. What causes a proof to be invalid? We already looked at that. And recognizing the common errors, there were 4 things that we had to be on the lookout for. Let's see if we can find some in these questions. Pedro is trying to prove that 2 equals 5. Good luck, Pedro. In which step does Pedro make his first mistake? Let's see. He says, suppose that A equals B. All right, fair enough. So if A equals B is step 1, he says he's going to multiply by -3 on both sides. Okay, we're okay with that. Step 2, add 5A to both sides. Okay, no problem. You can do that to both sides of an equation. Step 3, he says simplify. So -3A plus 5A is 2A. Yeah. And then -3B plus 5A he left alone. Yeah, that looks okay. So far, so good in my estimation here, Pedro. Step 4, subtract 2b from each side. Okay, that looks good, and that looks good. And then simplify again. So -3b and -2b makes this -5b here on the end, so that looks good. Wow, we're rolling right along. And then he's going to factor. So a common factor of 2 in the first side of the equation, the left-hand side, and then on the right-hand side, a common factor of 5. I'm okay with that too. Now, Pedro is going to divide both sides of the equation by a minus b. Uh-oh. Dun dun dun. We found a mistake here. Why can't you divide by a minus b? Because a equals b. And therefore, a minus b would have to equal 0. And this would be division by 0. Not allowed to do that. Step 7. So the incorrect, or his first mistake here, is all the way to the end. You almost made it, Pedro. Don't try to pull the wool over our eyes again. Cheyenne. That's a nice name. Cheyenne is trying to prove the number trick shown. Identify and correct her mistake. Okay, so the number trick says, pick any number, add 3, multiply by 4, subtract 12, take the square root, divide by 2, square it again to get your original number. Now Cheyenne started with n, and she ended up with n squared, so that's not the same. So she made a mistake somewhere. Let's see where it is. So pick any number. She did that. N is good, generally. So we're trying to do a deductive proof, so we don't pick an actual number. We pick a variable to represent a number. So we add 3, n plus 3. Good. Multiply by 4. So if we multiply all this by 4, we get 4 times n and 4 times 3. That looks good. Subtract 12. No problem. Take the square root. Okay, so hold on now. She's taking a square root, but she is saying that the square root of 4n is 2n. Let's think about that now. She should be taking the square root of the entire 4n. Remember your radicals unit now. And that should give us the square root of 4 times the square root of n, which should be 2 root n, not 2n. Okay, so this is where her mistake was. And we're going to pick it up from there. So for everything from here down will be invalid. So we're going to take her from this step to there. So the next step says to divide by 2. So to divide by 2, in our next step, we're going to have 2 root n over 2, which should give us just square root n. And then the last step says to square it to get your original number. So square root of n squared should give us just n. You square root something and then square it again, you get back to where you were. Okay, and that's the original number. So now we got it. So we've proven that the number trick works. Cheyenne just made a mistake. Okay, so don't forget, we've got to watch out for incorrect assumptions, invalid mathematical procedures, and also arithmetic mistakes or algebraic mistakes. Don't forget that circular reasoning thing we mentioned last time. That can come up, but circular reasoning is not really one that you have to identify. All you got to do is say, well, if somebody started with the thing they're trying to prove, they're in trouble. Okay? Okay, so I hope that helps. See you in the next one.